This video presents co-design and evaluation of an intelligent decision support system for stroke rehabilitation assessment. Rehabilitation assessment of patient status is critical to determine interventions. However, as it requires a time-consuming process, this assessment is infrequently performed due to the limited availability of therapists. To address this problem, prior work has explored the potential of technology-assisted rehabilitation system, which automatically recognize and assess patients' exercise. Significant recent research has focused on improving the accuracy of this system with complex algorithms. However, this system with complex algorithms still cannot perfectly replicate therapists' decision-making and provide explanation on their predictions. Thus, therapists could lose trust in this system and abandon their usage in practice. In this work, we co-designed a system after needs finding study with therapists, develop an AI-based system that improves its interpretability with feature selection, and evaluate its effects on therapist rehabilitation assessment. First, to gain better knowledge on current practices and needs of therapists during rehabilitation assessment, we recruit 9 therapists and conduct interviews, focus group session by asking their process of rehabilitation assessment, usage and opportunity of technological supports. Also, we observed 1 rehabilitation session. We found that therapists infrequently perform this time-consuming assessment and encounter various challenges and needs as this assessment relies on individuals' experience. They are uncertain on the exact definition of normality and have needs of validating with other colleagues and information on patients' status. Given these challenges and needs, we identify opportunities of technological supports to provide comparison between unaffected and affected motion to better define individual normality, predictive assessment from an AI system calibrated with another therapist, patient-specific analysis with intuitive graphics. Based on the needs finding study, we designed a system that automatically identifies salient features to predict the quality of motion and provide a therapist alternative perspective on assessment with patient-specific analysis. This approach represents patients' exercise with sequential joint position from a Kinect sensor and extract various kinematic features. As manually reviewing abundant kinematic features is time-consuming, this approach formulates feature selection with MDP, which aims to minimize the amount of kinematic features while maximizing the classification accuracy. For automatically assessing patients' exercise, this approach utilizes machine learning model with the label sensor data and explores various algorithms. Following the needs finding study and human AI interaction guidelines, we design and implement a visualization interface that presents the video of an exercise, feature analysis, salient image of motion, and joint trajectories. For experiments, we collected a dataset of 3 upper limb exercise from 15 post-stroke and 11 healthy participants. 2 therapists annotated this dataset to implement our approach and compute therapist agreement level. For evaluation, we apply leave one subject out cross-validation and also review the interface with the 2 therapists to find any potential usability issue. Overall, our approach with the reinforcement learning-based feature selection outperforms other machine learning models and achieve comparable performance with therapist agreement. Regarding the interface, therapists had an issue with understanding the names of features. Thus, we present features and let them speak out loud to convert them into easily comprehensible terms. For the user study, we compared therapists' experiences of rehabilitation assessment using 3 interfaces: traditional, that shows only a video; pre-score, that shows only predicted score; proposed, that shows both predicted score and an analysis. We address learning effects of a therapist by counterbalancing the task and randomizing order of interfaces. For evaluation, we collected the therapist's response on usability questionnaire, logs from the interface, therapist agreement level on assessment, and their comments. Overall, our proposed interface achieved higher scores on all perspectives of usability questionnaire. Specifically, therapists had higher usage intents on our interface, which provides richer information and reduces therapy's efforts on assessment with statistical significance. In addition, our proposed interface reduces the video playback events and significantly improves therapy's agreement. From the post-interviews, we found that therapies utilize patient-specific analysis as a source of information to understand the capability of the system and develop a mental model of the system to adjust their usage. Also, therapists consider our system as a good platform that can quickly bring interesting new aspects of a patient with intuitive graphics, simplify their assessment process, and facilitate their communication with patients. To conclude, this research demonstrates the importance of providing explanation of a system and human-centered designs that provide contextually relevant information for better deployment in practice. We further discuss a promising direction of research that explores interactive techniques for collaborative and personalized decision-making. Thank you for your attention.